Okay, and sharing my screen. Can everyone see? Got my console, my add-on window. Okay, cool. So, right, let's start with the README since that's a pretty good place to start. This homework assignment was about creating two classes, deck and card, which can get used by other programs to play a variety of games. There's some starter code in a lib directory. And there are some tests that exist. You want to use them. Let's move this. Sorry, folks, 1 second. There we go. That's what we need. Okay, so we are going to create the two classes, card and a deck. So we'll start with a card. Actually, we'll start really by bundle install. That'll get me any and all gems that I need. Okay, cool. So I have all of those things. Why I want to be able to have RuboCop to catch any and all convention mistakes, and also, of course, RSpec, so that I can run my tests. Linting in tests are extremely useful. You may have noticed that some of these tests are marked as pending. The reason that that's the case is that inside the spec directory, there is, there's this RSpec code, and this code describes all the different things that should be true, and it asserts that they will be true, but they might not necessarily. Some of these, though, where it says it, instead of saying it, it says X it or X describe. X is a way of telling RSpec to skip a particular bit of your test suite for now and just ignore it. So if you're writing multiple tests, you can write them and essentially comment them so that RSpec doesn't pay attention. Okay, so some of those tests are marked as pending, or they're commented out, but some of them are not. Okay, cool. Let's go ahead and get started. We want to create a card class, and it has to have the following publicly readable properties per the directions. Do I actually say that? Oh, maybe I didn't. All right, well, don't say whether or not it can be writable. Or maybe I said that in the outer README. Anyway, readable properties, rank and suit. And you can set these properties when you instantiate a new card. Additionally, it has an instance method called face card, which returns whether or not the card is a face card, Jack, Queen, King. So the rank is a number from 1 to 13. So if it is 11, 12, or 13, then face card should return true. Okay. Cool. So I've got some of this already set up. I've got my card class created. I've got an initialize method, and I have arguments that are being passed in, rank and suit. So I want to have instance variables, rank and suit. So I'm going to define at rank, which is the rank instance variable. Every card will have a rank value. And I'm going to set it equal to the rank argument that gets passed in the initialize method. Do the same with suit. Okay. So that was the first note that I have my tests here, right? And my tests kind of give me a framework for different features that I can try and implement one at a time. You can start with the tests just as much as you can start with the code. So it says card has a rank and a suit. It failed before. I just changed some code. Will it fail now? Well, run my, I'm going to run my linter on my code first just to be sure. Missing frozen string literal comments. Ignore that. That's dumb. Cool. RSpec. Okay. Card has a rank and a suit. Oh, right. This is a problem. The thing is that an instance variable doesn't have the ability to be accessed outside of the class. In fact, an instance variable is specific to the object that it is on and nothing else. You cannot directly touch an instance variable in Ruby. The only way that you can get at an instance variable from outside of that object is through a method. Methods are your only way to access and manipulate data inside the object. So we could create methods to do this. We could say def rank returns rank. And I could define another method, rank equals and do that. So if I call this first method dot rank, it'll return the rank. And if I call rank equals, it'll assign whatever that argument is to rank. I'll try that. Undefined method rank. No, I just changed. Oh, I didn't save. Okay, so it should say something different. No? Okay. That's all right. What I was driving at was we want to make a method so that rank can be accessed. AddReader is a method. It's a helper method for creating objects, for creating classes. And what it does is when you give it a symbol as an argument, it generates two methods. Well, actually, reader generates one method, a getter method. Writer generates one method, a setter method. And accessor generates read and write methods. So I'm going to generate two new methods for reading, or one new method for reading a rank and one new method for reading a suit. All right, so we had 11 examples, 8 failures, 2 pending. So if we do the math on that, that means one of those tests must have passed. And in fact, if we come up to the top, we can see that card now has a rank and a suit. Awesome. We also need to give this card a method, an instance method called faceCard. It's a predicate. Returns true or false based on some condition. And we said that a faceCard is a jack, queen, or king, which have ranks of 11, 12, and 13 respectively. So we want to return true if rank is equal to any of those things and false otherwise. So the cute way to write this is to say rank is equal to 11, or rank equals to 12, or rank equals to 13. I say it's cute because it's only a single line, right? But this expression is going to evaluate to true if any of these pieces are true, and it's going to evaluate to false otherwise. There's another way that you could do that also, I think, using includes. I'd have to double check. Maybe Ruby array include. So alternatively, we could write that, which is even shorter. Let's go with this one, though. All right, so I've written some code. So I'm going to run my tests. Returns true or false based on whether or not card is a face card. Undefined method face card for card. That's odd. Created the method. Did I not save? Let me save that again and clear. Oh, there it is. I'm sorry, I was looking too high up. Returns true, false based on whether the card is not a face card. So we now pass 2 of those test conditions. Cool, and that's all there is in the standard set for card. So we've completed step 1, creating a card class. Creating a deck class. So a deck has to have a publicly readable cards property. Following what we said earlier, that means that it's going to be add a reader cards. What's interesting about add a reader, add a writer, add an accessor is that in addition to defining the methods, they will also define an instance variable. So if for whatever reason we don't set cards in the initialize method, we don't have to define it there either, as long as we have add a reader, add a writer, or add an accessor. It'll define the instance variable along with the methods, if necessary. Okay, so we have a publicly readable cards property, and the array has to be populated with 52 new cards when we instantiate a new deck. Okay, so that's some stuff that's going to need to happen in the initialize method. Note that we're not taking any arguments here, because when we set up the deck, we set it up the same exact way each time. We could theoretically hard code it, but that would be a pain in the neck. So rather than doing that, let's automate it. So we're going to define cards, but how do we get what we need? Well, we need to have a deck of cards, right? And the deck of cards has 13 cards of each suit, and it has 4 cards of each rank. So what that means is we're going to need to combine different, we're going to need to combine different different sets of things. We're going to need to combine a suit with a rank. And one of our favorite tools for doing that is zip. Ah, okay, there it is. Sorry, just pulling up something. Okay. Oh, but there's one other thing that we should consider. Wait, hang on. Adam asks, even if you define attr accessor, you still can't access the instance variables? Just modify with the, so it's not attr accessor, note, it's attr reader. This is read only. It's only creating getter methods. So I can read the values from the object, but I can't change them. And Kelly, to your question, why can you use attr reader instead of attr accessor? Because I choose to. I don't have to, but it only says to make them readable, not writable. So I'm not going to assume that they should also be writable. I'm just going to do exactly what it says, which is make it readable. And add a reader.
So, Matt, can I ask you something really quick in the same vein?
Mm-hmm.
So if you were to make a getter, like you were saying, method, could you assign that output to a variable that you then pass into other methods? Would that work?
Wait, say that one more time. I'm sorry.
Could you assign like the return of the getter to a variable that you then pass into other methods as a parameter?
Oh yeah, for sure.
Okay, that actually just clicked in my head. I think that's going to make Ruby a lot easier.
Yeah, but I mean, you shouldn't need to. If you're talking about working within the same object, they can all access the instance variable. So there's no need to go out and then come back in.
What if you're going between objects? Like if you wanted to pass in.
In that case, you would need to get and then set separately.
Okay, cool.
For sure. Okay. What we would really like to be able to do with the initialize method is we want to essentially have a set of suits, which are spades, clubs, diamonds, and hearts. And we have a set of ranks. I could write this out 1, 2, 3, etc., but I'm lazy. So I'm going to cheat. This is a thing called a range, and it generates, it will repeat for every number from the beginning up to the end, and I can convert that range to an array. But if I didn't know this, I could also definitely write out 1, 2, 3, 4, etc. Okay, so I want some way of combining each one of these with one of these. Zip won't really do that. Zip, first of all, assumes that you have two arrays of the same size, and then it tries to combine them. These are different size, right? Ranks, there's 13 ranks and only 4 spades. So we need something a little bit different, but also we want to be able to combine it for it every single time. So there's actually another method that we can use to accomplish that, and it's called product. I'll paste the link to that. Cool. This is a useful method for things where there's 2 sets. Why make them symbols instead of strings? That's a good question. It has to do with what symbols are versus what strings are. Symbols you can think of as kind of single-use strings. You define them and they're constant throughout the entire duration of your program. There's, in fact, a term called a singleton, which is where something exists once and only once inside your entire program. And symbols are, you could say, singleton strings in a sense. It's conventional to use those when you're dealing with constants, and you have no choice but to deal in symbols when you're working with well, no, that's not quite true, but you will generally be working with symbols when you're working with keys in hashes as well. And they're doing certain things easier, particularly when it comes to writing code. So in the example of attr reader, the reason that these are symbols is that makes it easier for attr reader to actually define methods for those things and to be ensured that there are no duplicates, I believe is precisely what it is. But it is convention that you'll see symbols used as arguments for things like that rather than strings. coming back to product, here's the documentation on that. So if you have an array, you can get the product of that array with some other array. And it's going to produce all of the different possible combinations between set 1 and set 2. So in this case, if we have an array 1, 2, 3, product with 4, 5, we get back is 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5. Very, very useful. So let's actually use product in this case. We have our suits and our ranks. So cards is going to be this is a particular construction in Ruby where you can access, if you're iterating through an array of arrays, you can access the different elements in the child array with names. So in this case, suit product ranks. Well, actually, let's just look at suit product ranks for a minute. We can put that. If I have that, suits product ranks, we should see that output. And this is what it looks like. Well, that's maybe not the most clear when it prints out that way, but spades 1, spades 2, spades 3, spades 4, spades 5, spades 6, and so on. And for each of those, it's going to be an array containing spades and number, clubs and number, and so on. So if we choose to iterate through that, we can use the combination of suit and rank to initialize new cards. And in fact, we can not only initialize those new cards, we can put them directly into cards. So kind of first way of thinking about this is we say, oh, well, we have, or I'll say ranks and suits, since that's the order it is in the cards constructor, or initialize method rather. So in that case, we could produce a new card like that with a particular rank and suit. And it would do that for every different card that we might want. But we actually don't just want to create those new cards. We also want to put them into the instance variable at cards, right? So we could define at cards as an empty array and then just shovel it in. Or .push or whatever. But since we're creating an array of equal size to what we started with, it's actually, I think, easier to just use map rather than each. And to transform each combination of products, of ranks and suits into a card with that particular set of characteristics. Okay, and it looks like we successfully created 52 cards. We have 13 of each suit and 4 of each rank. There's our initialize method, but we need to define a couple more methods on a deck class, instance methods. We need to define count, draw, and shuffle. I don't see a test for shuffle. Oh, I must not. Oh, because yeah, that makes sense. Okay. So let's look at count first. What is count? Count is a method that returns the number of cards in the deck. Well, we have at cards, so the easiest way to do that is cards.length. Let's test it. Okay. Count seems to work. Cool. Next, draw. Remove the last n cards from the deck and return them as an array of cards. Okay. So if we want to draw cards, from a given deck, we want to be pulling off some set from the end. What are some ways we could do this? Just throw stuff out there. How can we pull things off of the end of this array?
You could use pop.
Yep, could absolutely use pop. It doesn't seem to care about the order either, so it doesn't necessarily matter how we do that. We could pop it and put it into new arrays. Any others?
You could do slice as well, right?
Not slice.
Couldn't you? You could do.
Or actually, is there a mutating slice? Deletes the element, returns the, yeah, actually, so you're right. Yeah, mutated slice bang would allow you to do that. Yes, that would work. So in that case, if we wanted to do that, we could say, I like that one because it's kind of elegant. At cards dot slice. So it's going to give us some set of elements and it's going to take them out of the array. And actually, slice is nice because it's fairly flexible. So we have to give it either an index if we want to have it like a single one, or we have a starting index and a length. That seems like the easiest one. So we want the last n elements. So we're going to start at index -1 times n. If we want the last three. And the length is n. That'll work. Any other ones? Oops. May have just spoiled the surprise. There is another one which is even more elegant, which is drop. So we can do pop, we can use slice, but the simplest one is drop, which takes. Oh, sorry, that's the first. That's the first ones. So it would be reverse.drop. In that case, well, no, because reverse is going to be the duplicate. What's the one for the last n? Is it tail? I'm gonna have to go check the documentation on this one. So if we go to drop is drop the first 10 elements. Doesn't link to. No, it doesn't link to its opposite side. Okay. Maybe it's take. No, that's still the first 10 elements. The same as drop. Just the one for the end. All right, there is another method on here that does that. I don't remember which one it is. We'll use slice then. Cool. So slice is going to give us a slice of elements of size n, starting from the end of the array. Run the tests. And hey, draw works too. Okay, so that's step 1 and step 2. Anyone curious about step 3 and step 4? Can I get like a thumbs up, thumbs down if you guys want to work through those together? Or if you'd like rather do something else, I don't know. All right, I'm seeing a handful of thumbs ups. So I'll go ahead and start working on those. So we have a 2S method on a card. How do I know that? Well, every object in Ruby has a 2S method. And the reason for that is that every object in Ruby inherits from a parent class, which if you don't explicitly define one is the object parent class. And the object parent class has a method called .2s, which takes that object and turns it into a string. You can actually test this out a little bit more dynamically. I can open up pry here and do a require relative. Okay. So I've loaded up my stuff. I can say card exists, deck exists. So if I create a new card, and it's rank and suit. So I'm going to say it's the 4 of clubs. Cool. So I've created a new card, has those properties. If I say c.toString, well, it gives me this, which is sort of the default behavior for an object. It is it's like a hash followed by the name of the class, followed by the location in memory where the object exists, funnily enough, followed by some other stuff, such as instance variables. Okay, but it's a method. And when you have a method in a parent class, methods can be overridden by a child. So we're going to take the card class and we're going to override the definition and overwrite it of the 2s method. So here's how we do that. It's actually surprisingly easy to overwrite. Just define a method with the same name. Now, what is it that we exactly want it to do? We want it to return a string in a particular format: ace of spades, king of hearts, 2 of clubs, etc. Okay, so we've handled the part of overriding the method already, so now it's just a question of building out the string. Cool. So I'm going to say rank name and I could just have some if statements. Actually, this should be state case. No one called me out on that. Ooh, you guys should absolutely tell me when I get something wrong, please. All right, so if rank is equal to 1, then it's an ace. Ah, sorry, you did. I apologize, Jason. You saw it. And this should be double equals because we're in Ruby. Rank is equal to 11. Jack, let's do that single quote per Ruby convention. So that takes care of our special fancy names for certain cards. By default, rank is going to be equal to, rank name is going to be equal to the rank turned into a string. But if it has one of these special values, we'll give it a special name instead. So that takes care of the rank name. How do we get the suit name? Well, we have the name of the suit, right? So I could go through a process to convert it, or I could just cheat. Since there's only 4. I like cheating when I can get away with it. This would be useful if, for whatever reason, our suit name and like the thing we wanted to display didn't necessarily display so evenly. In this case, they do, but and then we need to just return the string. So I'm going to return a string. And that string is going to have the rank name of suit name. Well, not suit names, because that's the hash, but suit names suit. For if the suit is hearts, then that'll be equal to hearts and so on. Okay. That's a lot of talky talk for me. I don't know if I believe everything that I'm saying. So I'm going to run rspec. I forgot to uncomment the test. Excuse me. So if I go to the homework tests, here's the tests that talk about 2s. So overrides default definition, instead turns something else. So updated the tests. Let's rerun them. Cool. The 2s works. Awesome. The only one that's left is this test, which we skipped. Card is comparable. So what is meant by comparable is that if you pick a particular card, you can meaningfully compare it to another card using less than, greater than, equals, etc. That's not something that just inherently exists. There is a module called comparable that is included in every single class that's able to do this. And it provides the methods necessary in order for that to happen. So this is getting a little bit more intense, right? But that's a reason it's a reach target. Here is documentation for the comparable module. Have you guys talked about mix-ins yet? No, you've only talked about direct inheritance, right? Okay. So inheritance is awesome. Inheritance means that we can save ourselves a lot of time by not having to write the same thing over and over and over again every time that we define a new class. The only problem is inheritance is kind of uptight, right? Inheritance is very, very strict. You can only inherit from one parent class. But what happens if you want to pull in stuff from lots of different places? Strict inheritance doesn't really deal with that. And in fact, the problem of multiple inheritance is something that has to be addressed in pretty much any kind of language. Some languages just completely disallow it. But Ruby has a mechanism for allowing you to inherit, in a manner of speaking, from lots of different sources of code. And that is using the mix-in pattern. Mix-in is actually kind of like it sounds. It essentially is like mixing in stuff from somewhere else. I think the term comes from like toppings on ice cream, where you have like vanilla ice cream and then you mix in sprinkles and you mix in chocolate chips and so on, and you make it more awesome ice cream for adding those things. So the same idea with mix-ins in Ruby. You can include a mix-in, and a mix-in would have to be a module, a Ruby module that contains some set of methods. But once you define that module, you can include it, and all of those methods suddenly become available in the class that you're accessing. So this is a way that you can kind of go beyond just the standard traditional linear inheritance pattern to incorporate all sorts of cool new stuff. Comparable is one example of such a module, and we're going to include it in the card class as a mix-in. So there's a couple of things that we need to do in order for that to work. And actually, this documentation tells us what. The comparable mix-in is used by classes whose objects may be ordered. In order for this to work, the class must define the funky thing operator. I've heard this called the spaceship most commonly, but it's a method. Your class must have a method with that name in order for the comparable mix-in to be able to do its job. When you include that module of methods, those methods are going to assume that your class already has this method and that this method will behave in a certain way because it'll try to call that method. So in this case, we need to define the spaceship operator. And the way the spaceship operator works is it compares the receiver, that's the object that the method's being called on, against another object, and it returns either -1, 0, or +1. And based on whether it returns -1, 0, or +1, this allows the comparable module to say, oh, this thing is less, or this thing is greater. The key about the spaceship operator is that is what allows you to define exactly how you decide which is greater and which is less. What's also nice is that because anything that is comparable must have this method, you can call the spaceship methods on things that are already comparable, such as numbers. In this case, we have two strings. And we say we want to compare to one string to another string. Well, .size is going to return a number. And numbers can be ordered. Numbers can be compared. So you can say 5 is less than 10. So because of that, numbers are comparable. And you can say, compare this number to that number. How does this apply to our cards? Well, here's how. We want to be able to compare. Oops. We want to be able to compare one card to another card according to the README, right? It says we want to sort it and sort the cards only by rank and not by suit. So in other words, the basis for comparing one card to another card is its rank. So in our spaceship method that we define on the card class, we want to compare the rank of one card to the rank of another card. So the way that we can do that is we can compare my rank to the rank of other card. Oh, that should be snake case. Sorry. Okay, why does this work? Why can I say this? Because rank is a number. Numbers are comparable. Therefore, the number class must have a spaceship method. So I'm calling the spaceship method on the number and comparing it to another number. This is fancy. If you don't like this, I understand. here's another way that you could do that. You could say if rank is less than other card dot rank, shoot, other card dot rank, turn -1. Else if rank is greater than other card dot rank, return 1. Else return 0. This is what's really going on under the hood. It's checking to see, you know, based on some conditions, which one is greater. This one says, oh, the left one, the receiver in this case, is greater rank. Wait, actually, should it be the other way around? I might have that backwards. Let me just check the docs. Whether the receiver is less than. So if it's -1, that means that the receiver is less than the other card. +1 if the receiver is greater than the other card. So this is the receiver, right? Do you guys understand what I'm saying when I say receiver? It's the object that the method is being called on. This, right? Essentially. So it's saying, okay, if this card is less than the other card, by whatever we define less to be, return -1. If it's more than the other card, by whatever we define more to be, then we will return +1. And if they're equal, then we return 0. So this allows us to define pretty much any basis of comparison between two kinds of objects, however we want that to be. And that means that once we have a way of comparing things, they can actually use less than, greater than, and so on, like in the test spec. As you can see, here we're actually calling less than, greater than, and equal to on cards. Not on numbers, on cards. And the reason we can do that is because we've made the card class comparable. Actually, I'm missing one piece, which is that I need to include comparable. Is it capitalized? No, right, not a string, it's a symbol. Or spare, rather. Cool. So we include comparable, and this is going to make the comparable module part of the card class, but all of the methods inside the comparable module depend on having a spaceship method. So we need to define the spaceship method as a dependency of the comparable module. And once we have that, that'll work. There are a whole bunch of interesting modules like comparable out there. Another one that's worth noting is enumerable. A lot of the fancy things that you can do with array are not actually defined inside the array class. They're defined inside a special module called enumerable that gets pulled into many classes, not just arrays, but also strings and ranges, and actually lots of stuff. Lots of stuff is enumerable. Okay, so there we go. We've created this stuff. Let's see if it actually passes the tests. Hey. Okay, cool. So we made all of that work. We created a card. We created a deck. We gave both of these some methods, some instance methods. We overrode the toString method on the parent class. And finally, we made cards comparable. Okay, I want to pause. And I'm going to stop sharing and pause the recording. Actually, I'll leave the recording going. Do you guys have questions on specific things that I've just shown you? I imagine that you probably do. You just saw some weird stuff.
I feel like the questions typically come when you try to do it yourself.
Okay.
And then you're like, okay, this isn't, I thought it made sense. And then, so.
All right. Well, I think that's an excellent point, Eric. How about we take a couple minutes and we open up Replit or what have you, and we recreate the card class specifically. Don't worry about the deck, just the card. You don't need the deck in order to compare individual cards anyway. And you can skip rewriting the toString method. That's just being fancy. Create a card class and then make it comparable.
I have a question.
Rachel.
Why don't you have to define what other card is?
It's being passed in as an argument. So when you call the greater than, less than, or equals methods, so when you're writing 1 greater than 2, right? It looks like an operator, like we might have seen from JavaScript. It isn't. It's not an operator. It's a method. Greater than is a method that exists on certain kinds of objects. Specifically, it exists on objects that are comparable because they can be compared, right? So every comparable object has methods like less than, greater than, equal to. And when you do that, that method gets called on the first object and compares it to the second object. And those methods inside the comparable module will rely on the spaceship method that is defined for the number. That number has a spaceship method that exists, and that defines how you compare one number to another number. But it's the reason that it takes an argument is that comparable expects it to. Comparable is going to be using the spaceship method in order to do its job, and so it needs that spaceship method to be set up a specific way. Sorry, I'll turn that to buzz. Okay, does that help clear things up a little bit, Rachel? Awesome. Yeah, methods. Everything is objects and methods in Ruby. Everything. Except for the things that aren't, which are some of the very interesting things. But pretty much everything is objects and methods. And so that means that all the stuff that looks one way often is not. You're dealing with objects and objects methods being called on stuff. And that's all it is. What that means is that actually any class can have pretty much any method. You can define plus method for a string and have it mean concatenate. You can define a plus method for a number and have it mean from addition. You can have a plus method on an animal class to create some weird chimeric hybrid animal. You can define whatever these operations mean because they're just methods and they're totally customized. They're totally at your discretion. And you can overwrite them at any time. That's also true of JavaScript, by the way. In JavaScript, you can overwrite methods that come in from the prototype of your constructor. Similar idea. And so you can redefine methods as you need on the fly. Pretty cool. Yes, that's so true, JJ. What you see is, in fact, often quite far removed from what is. Particularly with Ruby. Ruby really tries to emphasize magic in order to make your life easier as a dev. But part of the problem with that is that it is kind of like hiding and disguising what's actually going on under the hood. And so when you move beyond the level of kind of beginner level Ruby programming and just sort of like getting Ruby code to work to more intermediate or advanced level Ruby programming, you face a bit of a steep incline at times because there are certain key ideas that you don't necessarily get when you're learning Ruby as, you know, just the basics of Ruby. But some of those underpinnings have very interesting and complex consequences. I guess that's true of any language though, right? but languages that are high magic specifically. On this magic spectrum, Ruby is like on the high magic end of the spectrum, and JavaScript is like on the slightly lower magic end of the spectrum. And all the way on the bottom is like C and COBOL and assembly and all that stuff where it's very, very, very low magic. But Ruby is a very high magic language.
Hey, Matt?
Yep.
Did you address how you would approach the ace card equaling 1, rank of 1 in that comparison, and how you deal with that?
I believe that I did. Well, okay, so in this particular case, it is sorted by rank. So it would go ace 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, because there is nothing really special about being an ace in this definition of a card. It's just the rank that is number 1. And the only time it being an ace comes to the fore is that when we change the toString method, we say ace. Otherwise, it's just rank 1. Now, we chose that. It doesn't have to be that way. You can choose to define it differently if you want.
Right, but I mean, in that comparison function, you're saying if rank is less than other card rank,
yep.
And so you're saying if 1 is less than 3, then it's going to be true. When in fact an ace is...
If 1 is less than 3, then it's going to say that the card with rank 1 is less than the card with rank 3. And so if you ask Ruby to then take those elements and sort them by some ordering, it's going to sort the ace in front of the 3, in front of the 10, in front of the king.
Okay. So in this comparison, we're not actually comparing like the card value then. I mean, like the...
We are. We're saying, well, we're not comparing the, I don't know what you mean by value specifically, but we're comparing the cards' ranks. In other words, if we sort cards, cards are sorted by their rank. That's basically what we've established here. We say, this is how you sort cards. This is how you determine which cards come earlier and which cards come later. It's based on their rank.
Okay.
Comparable, the spaceship operator is very interesting, and I think maybe a better name for it than spaceship is like scale operator. Not like a scale, like a bathroom scale, but like a scales of justice type scale, you know, where you've got like the two things hang down and it goes one way or the other. That's pretty much what's going on with the spaceship method. If both sides are equal, it gives a 0. If one side is heavier, it gives a -1. If one side is heavier, it gives a +1. And with that spaceship operator in hand, the comparable module can do lots of things to allow you to easily compare. So that's your mind-blowing of the day. Have you guys seen the enumerable module before? Has that like come up in any of your reading? Yes, no, maybe so. It would be worth your while. So you know how I'm a big believer in bookmarking the key pieces of documentation that you're going to refer back to rather than trying to remember a lot of stuff. So in JavaScript, I was like, bookmark array, bookmark object, bookmark string, and then you can look at all those different methods. For Ruby, I would say also bookmark array, bookmark string, bookmark hash, because hash methods you're going to need to use, certainly, and bookmark the enumerable module, because most of the array methods that you like using come from there, and that's where their documentation lives.
Hey, Matt, can you say that one more time? The enumerable module, the hash, the array, and which other ones?
Yeah, so my short list for Ruby for stuff to remember is bookmark array, bookmark string, bookmark hash, and bookmark the enumerable module. Other stuff I might throw in there, bookmark, maybe number, or bookmark math. Math is a good library to be familiar with. Bookmark CSV if you want to read. Yeah. If you want to be comfortable with reading from CSV files, CSV one is really, really useful, as you might imagine. But yeah, have a short list. And I would say the ones that I gave you, like string, hash, array, enumerable. Christine adds number. That's a good point. Number, symbol, maybe. No, forget symbol. Do that. But that short list, those should be the ones that are in your pocket. You have those ready to snap out at a moment's notice because you're going to use them. And actually, to be honest with you, that's kind of how I go about learning any new language. I try and zero in on like the documentation for those specific elements of things because they're what come up everywhere. You always need to be dealing with some sort of a list-like data collection. In Python, I think it's called a list. In most other sane languages, it's called an array. In JavaScript, key value pairs are called objects. In Ruby, key value pairs are called hashes. But they're still the same kinds of things, more or less, and so on. So getting comfortable with like the sort of common elements and common themes from language to language, make it easier and faster for you to begin to get moving quickly with a new language because you can zero in on the things that you need to know first. I hope that's good advice. Is it clear advice at least? Cool. Alrighty, so this is it for homework review. We ran, I guess, a couple minutes over, but it was questions, so I'm okay with that. I'm gonna do some general review here for the next hour, or no, half hour, because you guys have outcomes today. I believe, right? Is that right, Christine? They have outcomes today? I think so. It was on the calendar.
That's right.
Cool. So that is going to be at, I assume, 4 o'clock, the usual time. Yes. So let's do some open review for the next half hour. Or if you guys don't feel like that and you want to take a break before outcomes, that's fine too. Just make sure that you're back in, or that you're in the outcomes room at 4 o'clock so that you can get started with that stuff. Okay, I'm going to stop this recording and create a new recording for the open review.